All right, we are finishing up section 2.2. We need to do regression equations. These are not all power regressions like you had in lesson 2.1. These are, you're going to have to graph them and decide what kind of regression equation fits the best. And then we're also going to work on finding equations from graphs, which is, of course, a math teacher favorite. All right. This is what your worksheet looks like. And unfortunately, we need to type all of this in. So we need to go to Stat, Enter. And I am going to sadly clear out all of this, and I'm going to have to retype it later. And type in this is data about an oil tanker, time in hours, and the rate at which it is leaking oil. How far out does it go, guys? 10? Anybody missing a list 1 or list 2? All right, if I manage to get them typed in, you must have them by now because I'm slower than molasses. Okay. We need to look at the graph next. And it's already sketched here for us, so hopefully it's going to match that picture. Anybody remember the steps to get to the graph? If you have the plot turned on, yes, zoom stat is definitely going to have to happen. But first we need to turn the plot on, for most of us anyway. So second y equals, enter, enter until the black box stays around the word on. Make sure it has the scatter plot chosen and list 1, list 2, and whatever kind of mark you want. You may also want to go into y equals and clear out what you have. I have a lot of garbage in there. Then do zoom 9, and you should get a picture just like theirs. Whose is not working? Because we have to redo the regression to fit our new data, this data. Are we ready now? Okay. Now, we were doing power regressions last time. Power regressions have a shape that looks, let's see if I can use my finger to do this, kind of like that. Is that the shape for this? Nope. Not so much. I looked at this and said, parabola. What do you think? Yeah. Looks like could be a parabola. All right. Before we go to the next screen, please note right here it says that this is the leak in hundreds of liters per hour. We're going to need to know that in a minute on the next screen here. All right, it resembles a parabola, so we're going to, instead of using the power regression, we're going to use the quadratic regression. So, how do we get to the regression equations choices? Stat, if I turn off the ink here, stat, arrow to the right. Now, as you scroll down, there's a whole bunch of choices. You can do quadratic, cubic, quartic, and actually a quartic would probably work just as well as a quadratic for this, because same shape. Line of regression, which you are going to need on the homework. One of them is like perfectly linear, okay? After you do the stat plot. And then further down are some we're not going to use yet, logarithmic and exponential. But power regression is a choice you could make as well today. All right, we're going to go with quadratic on this one. So go up to choice 5. And if you have an older one, you still need to type it in and store it. So we're going to do list 1, list 2, and then go to store regression. Vars key, arrow to the right, and I'm going to go ahead and store this in Y1. Anybody not getting the R values? Okay, you can go to mode.
Oh, I know. Yeah,
and turn it down to diagnostics on.
Gotcha.
Anybody else not getting the R or R squared? Everybody's got it on? Good. Okay, I'm going to actually try something, and I ask you to try this at the same time. Go back and go stat, right arrow, and go down to power regression, and hit enter, and list 1, list 2, but store this one in Y2. So when you go vars, arrow to the right, function, make sure you go down and pick Y2 and hit enter. All right, then go to your graph. The first one it will graph is the quadratic. The second one it will graph is the power. Which one seems to fit better? Okay, the quadratic fits much better. All right, but it's a comparison by graphing 1 in Y1 and 1 in Y2. We could have done instead the quartic. Remember I said that one might work? I'll just show you. You don't need to do it. I'm going to put that one in Y2 right over the top of that one that obviously wasn't working. And I don't think you're going to see a whole lot of difference, okay? There's the quadratic. Not even sure. Oh, there's the quartic coming through. Very, very little difference, okay? All right. I am going to erase what I have in Y2 because I don't want to be confused. It told us to do a quadratic. Now we need to write that down on this line. It's y equals negative point thousandth is 3 places. I'm sorry, 409. Tenths, hundredths, thousandths, x squared. Okay, yeah, I need to get my tablet going because this is not, using my finger is not going to work very well. And what was next, guys? Okay, hang on, I don't know what's going on here. 2.762x. All right, everybody get something close to that? Now, the correlation coefficient this time was an r squared, not an r, but we're just going to go with it. It's what's on our screen, and it is... Okay. Where am I getting those numbers? They should be what your calculator came up with when you did the quad reg. Mine are stored in Y1, but I could just go back and have it come up on the home screen. If I go back and do the quadratic regression, it'll say here y equals ax squared plus bx plus c. A equals negative 4.09, B equals 2.76, and C equals 16.27. If you're not getting those numbers, it may be that you put something in wrong. Try the quadratic regression. Did everybody else get mine?
Yeah.
Yeah.
Oh, you have one, but you should be another. There, you got it. Okay. Anybody else have a question? All you have to do is type the littlest thing in wrong and you'll get different numbers. All right. Let's finish this quickly. It says use the model to estimate the flow at 10.5 hours. We have stored the equation, so now we can go to the table, second window to make sure it says ask, and then second table or second graph to the table, and we're supposed to put in 10.5 hours. It doesn't matter what else is in there. Just type 10.5. I got 0.17 roughly. Did anybody else get 0.17?
Yep.
Okay, now the issue is, yes, it is in hundreds of liters. 0.17 100 liters per hour. If we multiply that by 100 to get rid of that hundreds label, what will it become? Two places, 17 liters per hour. And finally, I like that they do this, but I don't think that they do this on your homework. It says use the model to determine the rate of flow. When was the rate of flow 1,000 liters per hour? Okay, first thing, 1,000 liters per hour is how many hundreds? 10. We'd have to divide by 100. So it's actually 10 hundreds of liters. Because it's a y value and we're trying to go backwards, we would want to go to y equals and type in a 10 somewhere further down. Doesn't matter, y2, y3, somewhere put in a 10. And then find where they intersect. We want to know where it hit 10. So there's the line at 10, and we go back and do second trace, intersection, enter a bunch of times until it says the intersection is at 8.5. Come on, silly thing. And that's an X value, so its label is what? Yeah, just hours. So about 8.5 hours after the leak, it was leaking at 1,000 liters per hour. Any questions? All right. Yes. On this next one, we're going to do X and Y, list 1 and list 2. This is, the further a planet is from the sun, the longer it takes to complete an orbit. So this is the distance in some kind of units, I don't know, and the days for one orbit around the sun. Okay, can you guess which planet is us? We have 365 days in a year, right? Okay, so type those in list 1 and list 2. I'm actually going to pause this video because it takes... Get this out of here and figure out what's going on. Okay, so we typed all this in list 1 and list 2. The next thing we need to do is go to y equals and clear everything out. Now, this is a way different numbers than we had earlier. So we need to do what to get a new window? Yeah, zoom stat or zoom 9 again. Okay? Anybody get that?
Yep.
Okay. We could probably do a line of regression and it would fit fairly well, honestly. Okay? Power regression. You could probably even do a quadratic and it would kind of fit. Okay? I used a power regression here. We can do a line in one and a power in one if you want to see the difference. But let's go stat, right arrow, down to power regression. We did this the other day. It is all the way down at A. And again, I'm going to store it in Y1. Are you getting pretty fast at all this, guys? I'm not. We know that, but... All right. So for power, did anybody else get these same numbers, or have I messed something up? 367? Point something. Yay, that's what I have. X to the power of 1.501, maybe, if I round to thousandths. And R is 0.9999, yeah, something crazy.
I just got 1.
Yeah, you can put 1, but it's an excellent fit. If you saved it, you can now go to the graph, and it hits every dot. Okay? Did it ask us to make a prediction here? I don't think it even did. Can anybody come up with a question? What would you predict using this? My thing was, what if we discovered a new planet between Earth and Mars? Okay, this is Earth, right? This next planet away is Mars, am I right? So if we discovered a new planet somewhere in there, we could type like x equals 1.25 in and figure out, estimate how long its orbit might be. Okay, let's not even bother, but I just wanted you to think about, I try not to have you do things just for the sake of finding an equation that we don't ever use. All right, let's go to the next one and put these in. It's the last one we're going to have to do this for. So go ahead and type these in list 1 and list 2. Do your scatter plot and draw it on your paper, and then decide what you think a good fit would be. And I'm going to pause while I type these in again, or the video will be very long and boring. All right, I have them typed in finally, and I'm going to go to y equals again, clear out my old equation, and do a new zoom stat. I don't know. Does yours look like that, or do I have something typed wrong? Looks just like that? Okay. I kind of decided maybe a cubic, though a power is a possibility as well. So this is what I'm going to do just to show you the difference. Again, you don't have to. You can just do the cubic if you want. But I'm going to go stat. First of all, make sure you do a sketch on your paper. I should probably do that quick. Now that I moved it off the screen, it's not going to be very accurate here. I don't know. Looks vaguely like that. What do you think? Good enough for me. All right. So stat, right arrow. We thought cubic, which is going to be list 1, list 2, and I'm going to save that one in Y1. It doesn't give you an r value for a cubic, but it does give you an r squared. Before I erase this from the screen, since we do know that that's what we're going to write down, look carefully at this before you write it down. What's going on? Anybody see some really weird stuff? Am I going to write down y equals negative 3.87x to the third plus 1.53x squared?
Oh, no, I see.
Look at that back there. It's got that garbage e negative 8. So that's just the way I wrote it down because I was lazy. I wrote 3.87 times 10 to the negative 8 x cubed. It is a very tiny value. Plus 1.53 times 10 to the negative 4, or 0.000153 if you want to write it that way. X squared plus, oh, minus, my bad. Minus 0.1359x plus 167. Yeah, look good enough? All right. I just wanted to show you the power one just so you could see the difference. So I'm going to go ahead and do that in list 2. You don't have, or in Y2, you don't have to. Shoot. Well, like I said, there's not very many of these on the homework. All right, so here's what it looks like. There's the cubic hitting most of the dots, but what does it do at the end? It kind of starts to go back down, right? And there's the power. The power doesn't hit as many dots, but it continues to go up. So you'd kind of have to look at the data and decide which it really seemed realistically would happen. I'm just going to go with the cubic because if you look here, let me show you. This is the important thing. They want us to do an input of 800 calories. If you go to your table and you type 800, I have put in a Y1 and a Y2. You will see the difference here. Using Y1, which was the cubic, I get 136. Using Y2, which was the power, I get 140. Is that a huge difference in caloric output? Probably not. So with our cubic, we got an answer of, come on, mouse, where are you? 136.45, 136.5 calories. All right, and then pause the video one more time to see if anybody has any questions on this stuff. All right, for the second part of the lesson, we're going to go to the back of the worksheet. And when we are no longer doing regression stuff, guys, you want to go into y equals and clear out all of this, including turning off the stat plot, or it will not graph the polynomials you want it to graph. So go up onto the stat plot here and hit enter, or just go second y equals and turn it to off, whichever one you want. But in a minute, when we want to check our graph answers, if it's still has a stat plot on it, won't work. All right, these are my favorite because I'm a math teacher. We love puzzles. We are to come up with an equation for this. We did these with quadratics, okay? We did these with quadratics, same process. What are the zeros for this picture? Okay, we have a 0 at -2, -4/3, and 1/3. This is on worksheet 4, side B. Is everybody with me? Okay. We can write this in factored form 2 different ways. We can write x plus 2, x plus 4/3, and x minus 1/3. And that factored form would get us those same 3 zeros. Does anybody want to write it a little bit differently? X plus 2, how do you want to write this one so that it comes out a 4/3? If you multiplied through by a 3 right there, it would be 3x plus 4. Would that give you a negative 4/3 for the 0? Okay, so what would we multiply this last one through by? Okay, a 3x minus 1 would give us a 1/3. It doesn't matter to me which way you do it. And I'll show you why in a second. All right, when we did these with parabolas, we also had to find the stretch. Unfortunately, we're not finished, okay? You need to figure out that stretch. Does anybody notice right away what's wrong with our equation? Is the end behavior right for a regular cubic? No, it's flipped over at least, right? But we got to figure out what the stretch is. They give us an extra value here. On all of the questions, there's some value shown that you can plug in. 0 is a really nice one to plug in, but if the graph goes through 0, 0, you can't use 0, okay? Because there's no stretch there. But ours, we can. We're going to put in a 0 and get out a 16. So right above this one, I'm going to write 16 equals A. And then if I put in a 0, I'd have 0 plus 2, 0 plus 4/3, and 0 minus 1/3. I'm also going to do it under here in this version. 0 plus 2 would still be 2. 3 times 0 plus 4. 3 times 0 minus 1. Now we'll get a different A value depending which way I wrote the equation. The one down here is pretty easy to solve. I get 16 equals A times, if I multiply all that, I get negative 8. Yes, I'm dividing, okay? Had trouble with that last period. Some were confused, but we're dividing. We get A equals negative 2. So our answer in the nice form would be negative 2 and then this. But it's okay with me if you did it this other way without worrying about multiplying through by anything here. If you did that, if you multiply all this, you get negative 8/9. How do you get rid of that, guys? Multiply by a reciprocal. So you would do 9 over negative 8 times 16, which would reduce to negative 18. Yep. So this one could have been a negative 18 if you left it all factored. All right, so what I want to do to show you that this works, I'm going to type both. You guys beat me, okay? Go to y equals, turn your calculator on. Mine is not coming on. Go to y equals and type in the equation. You don't need to FOIL it all out. We're just going to type it in as is. If you have a color calculator and you want to put them both in, it's kind of fun because you will see that it will do one right over the other. But you only need to put one of them in. Whichever one you would have written down on your paper, go ahead and put that one in. Okay, what do we need to do? Is this going to graph in the window that we have on our calculator from using Zoom Stat? No. It's not, a Zoom 6 is not a very nice window either. What is a good window, guys? They gave it to us. Yeah, use the window they did. They did, I'm going to go -4 to 4. And what did they do? -60 to 60, does that sound right? That's what the picture shows, the actual graph there. All right, this is the picture I get. And notice the little thing over here says it's still going. I could actually go back here and do this. All right, I'm just being tricky here, but watch. Here's the first one with the -18, and here's the second one. Comes through right over the top with the -2. It's the same graph. All right. Trace. At 0, it's at 16. At -1/3, that's not right, is it? It's +1/3. +1 divided by 3 gives me a 0. -4 divided by 3 gives me a 0. And -2 gives me a 0. So I have just checked that it works perfectly. All right. I want us to try number 4. Okay, I'm going to come help you. I'm going to turn this off. Go try number 4. All right, going on to number 4, there's some trickiness going on. Couple things. Anybody notice something important? Very important? It bounced, yes. You got it. It's doing a bounce here and a bounce here. And it goes through 0, 0. Okay. So tell me the factors. Assuming this is right at -3, we'll have a factor of what? X plus 3. What would make it bounce? Quantity squared. Actually, any even power would work. We're just going to go with the easy one with a squared, okay? And on the homework, it says, write the equation of least degree. In other words, don't go power 8 just to be funny, okay? Just leave it power 2 if it's doing a bounce. Okay, what's happening here? It is bouncing at 5/2, so we could write either x minus 5/2 squared, or we could write, how else could we write that one? 2x minus 5. But there's one more. This is definitely not a degree 4. Where's the other 0? At 0, 0. So how do we write that? You could write x minus 0, or you could just put an x out in front. Okay. We need to do an a value, and we need to plug a value in to find that a. Plugging in 0, 0 will not work. That's why they gave us this value right here. It says put in a 1 and get out a -28.8. -28.8 equals a times 1 times 1 plus 3, which would be 4, times 1 minus 5/2, which would be -3/2. You want to do it that way? Can I just do this one and be done with it? 1, 4, and 2 times 1 minus 5 is -3 squared. So we get 36. Did anybody get 36 over there? -3 squared is 9. 4 squared is 16. I lied, it's not 36. What's 16 times 9? 144? Okay, now I need to know what -28.8 divided by 144 is. -0.2. So, an equation that works is -0.2 right there. Okay? If you do it this way, you get a different answer. I don't remember what it is. Anybody do that one? 4 squared times... It's -0.8 if you do it the other way. Okay. You need to finish this worksheet for your homework. Please listen closely here. You also need to do this book assignment. Watch up here. Guys, I got 2 minutes. Watch. The first 3 you are assigned are find the best polynomial function. Then these are yes or no questions. Can this be a polynomial function? Remember, it's got to be a smooth, continuous curve. These are write a polynomial function of degree whatever that has the following 0. So if it's degree 3 with a 0 at 3, yeah, that's all you got to do, okay? Then this is tell, is it even or odd? Is the leading coefficient positive or negative? That's all you got to do on those. And then there are some questions where you have to write an equation like we did on the worksheet, okay? Test next week, so get started on this. You do not want to leave all this. It's homecoming week. Get this done this weekend.